Hello, today I'm going to talk about what's electrical current. However, we're also going to basically talk about the Ohm's law and how to use it. But the main topic that I want to learn is electric current. So, first of all, let's say we have a red dot, right? That red dot is going to represent an electron. So the electron gets pushed by the battery or whatever this can be. So something that is a battery basically. So basically a battery. And it goes this direction. So fully around the circuit. Electron is a type of charge. So charge itself has three kind of topics that we would be able to talk about, which are protons, and they have a positive charge, neutrons, and their charge is neutral or a zero, and electrons, which we are going to talk about today, they have a negative charge. So we can, in an exam, the electrons can be called as charge also, so just know that. And usually the questions ask like about how quick the charges go through the circuit, and it would say something like rate of flow, or like you would just say the time, however rate of flow. So that then leads us to an equation, and the equation is current equals current equals to charge divided by the time. So let's say you have the charge, like the electrons, but you want to know what's the current, which is basically like how it's going, if that makes sense. However, you can also rearrange this equation, and this is kind of a rearrange equation because usually it looks like the charge is the subject and it equals current times time. So basically, current is how quickly the charge moves. And in short, current is so seen as a I, charge is seen as a Q, and time is seen as a small t. And more importantly, I think, are the units. So the unit for current is capital A, which is ampere. For charge, it's C for coulombs, and for time, it's S for seconds. So these are kind of what the units are, what they're measured in basically. The example question is, in an appliance in a circuit, there's a total charge of 5C. Don't worry about the word total, it's basically the charge that flows. The current is 10 amperes. Calculate the time the application has been for. Okay, so first of all, let's just see what we have. So we have the charge. The charge is 5. The current is 10. And we don't have the time because we have to find it out. So let's write the formula. Q equals I times time. And we have to rearrange the formula to make it so that t is the subject. So that will be t equals charge divided by I. So that will be 5 divided by 10, which equals to 0.5. So the answer will be 0.5 seconds. Now let's just quickly talk about charge. Charge is a measure of total current that flows within a certain period of time. So you know how we worked out the current, right? So in the most basic words, charge is like how much current goes in, let's say 5 seconds. That's going to be the charge. So many like to use the water analogy, like where current is the rate at which the water is floating through the river. So imagine the current is the water, right? Current is how fast it's flowing, right? However, the charge would be the total amount of the water that would float down within the hill, in a certain time limit. So like imagine a bucket, right? And let's say how much it will get filled within like 5 seconds, right? Like you just put it here, like it's a big one. How fast will it get filled or how much? So that's kind of the idea of charge. So we already kind of talked about this, but like just quickly again, charge is the smallest q and it's in coulombs. I is in ampere and it's current. T is time and it's measured in seconds. So a question might look something like this. So a kettle draws a current of 12 amps and takes 50 seconds to boil. How much charge passed through the wire? So basically, in these 50 seconds, how much charge has been passed through? So charge is Q, and we have the current, which to 12 times 50, which equals to 600. So that would be 600 coulombs, and that's a C. So the next example question is a phone charger transfers a total charge of 43.2 coulombs over a period of 2 hours. What is the current flow through the wire? So look now, don't be scared of the kilo. Kilo is basically 10 to the power 3. I did a video about that, my first video. I'm pretty sure it's about the units and all that type of stuff. And then the 2 hours, you divide it by 60 so you can get it in 120 minutes. And then you divide this by 60 to get 7,200 seconds. And I equals charge divided by time. So we do 43,200 because I forgot to say this is equal to 1,000 because 10 times 10 times 10 is 1,000. So this is 33,200 because basically what happens is because of the kilo we times this by 10 to the power of 3, which equals 2. So we get this. Then we divide it by the time. The answer is 6 and unit is ampere, so this will be the answer. So we have a battery and the left side is the positive, the right side is the negative. And in questions, the current goes through the left to the small, like the positive to the negative. So that's the current. However, in reality, it goes negative to positive. So it goes like this. However, that doesn't matter. Just keep that in mind in case there's like a theory problem. So we need to know the Ohm's law, which is voltage times current and resistance. Resistance is basically like the resistivity of a material to electricity. So let's say, you know how plastic plastic doesn't like let electric flow, and the metal does. That's kind of the resistivity. It all depends on the material and all that type of stuff. So it kind of gives, like, you can say that it gives a limit. For example, like the resistor, it gives a limit how much current can flow so it doesn't, like, blow up. So let's say you keep the resistance constant and you increase the current. What do you think would happen to the voltage? It would increase. Same with the different part. If let's say resistivity is the same, like it's constant, and you increase the voltage, the current will also increase. Remember how I said like resistance, how much current goes through? If you increase the resistance, the current decreases. However, we also have to know that electric power is a product of voltage and current. And for this equation, there are 3 terms. So if you replace V with IR, because as we know, V voltage equals current times voltage or resistance, I mean, you'll have IR brackets I, which will equal to I squared R equals to P. If you replace I with V over R, because I equals V voltage over R, as we can see from this equation, then you'll get the second formula, which is V squared times R, divided by R, because like there's two V's, remember? It's in watts, and it's the W. However, this is the way, like it's just the third one. So these, basically, these are the three ways. Sorry for the confusion at the start. So the first example problem is a current of 30.8 amps flows in a wire for 12 minutes. How much charge passes through any point in this circuit during this time, and how many electrons would this represent? So first of all, we have to convert this into seconds. So times it by 60, which will equal to, so we will do 3.8 times 7020 equals, so and that's 2736. Now the second one, so in one electron there is 1.6 times 10 to the power of minus 19 of coulombs. So if we times 2736 times 1.6 times 10 to the power of 19 equals to, be 1.71 times 1022 of electrons. So the next example problem is that a 9-volt battery is connected across a 250 ohms resistor. The ohms is just a unit for resistors. And the first question is how much current passes through the resistor. So we have the voltage, we have the R, so we need to find the I. So I equals V over R, which is let's just put it as 0.4. How much power is dissipated by the resistor? And we know that milli equals 10 to the power of minus 3. So technically 36 milli amps equals 0.036, because times this by 10 to the power of minus 3 equals the same. So we're just in a question we will be able to do this. However, I don't see that much need. This is the answer for the first one. For the second, how much power is dissipated by the resistor? So power equals I squared and the resistor. The reason we're using this formula is we have the I and we have the R, so why not? The 0.036 squared times 250 equals watts, because we're talking about power. And the third question is how much power is delivered by the battery, and is basically kind of the same thing, because this time we use the formula P equals VI, because we have like V voltage is like the whole circuit, so we kind of need to think about, like, it's kind of about the question. So over here we also had to talk about the resistor, so that's why we used the resistor. And here we talk about the power dissipated in the battery, so we talk about basically the voltage, so we also need the voltage. Hopefully that makes sense. So in general that would be 9 times 0.036, which will equal to the same as this, which does make sense because this is how much is dissipated and this is how much is delivered. So if something is delivered, it has to be taken out because there can't be just some left. Let's say there's a 1 left. The next time it gets delivered, there's 1 more, and then the same amount as this goes out. So it will just stack up and like kaboom. So the next example problem is a 12-volt battery is connected to a light bulb and draws 150 milliamps of current. What is the electricity resistance of the light bulb? So first of all, let's transform this into the proper amps, which will be 150 times 10 to the power minus 3, which will just be 0.15. So the voltage equals 0.15 as 12, and we have the R, so R equals 12 over 0.15. Which is equal to 80. The unit is ohms. How much power does it consume? Well, we can just use the formula P equals VI because it doesn't matter which one we use. So the voltage is 12 times 0.15, so the answer will be 1.8 watts. You can use the I squared times R, it will give you the same thing. Now part C, how much will it cost to operate this bolt for a month if the cost of the electricity is 11 pence per kilohertz? So we know the power is 1.8 watts. And first we have to convert watts into kilowatts, which also we have to divide by 1,000. And then we find out how much out. So 30 times 24, because there's 30 days in a month and 24 hours. So then we times that by the hours times 70/20, and then we times that by 0.11. So it will just cost $0.14 because over here we're in dollars. Even though I'm in England, let's go. Next problem is a motor uses 50 watts of power and draws a current of 400 milliamps. This looks like a milli. And our first question is, what is the voltage across the motor? So P equals VI. Our amps is 400 times 10 to the power minus 3 equals 0.4. So we just do P divided by I to give us voltage. So that will be 50 divided by 0.4, which is, so the answer will be 125 volts. Our next question is, what is the internal resistance of the motor? So now that we have the voltage, we can calculate what's the resistance. So V equals IR. We have the voltage, we have the we have the current, so, which equals R. So 125 0.4, and so there's 312.5 ohms of resistance. Last question is 12.5 coulombs of charge flows to a 5 kilo ohm resistor in 8 minutes. This time we have something different. So 5 kilo, we did have this kind of before, so 5 times 10 to the power 3, because kilos are 10 to the power 3, so that's 5,000 ohms resistor. And our first question is, what is the electric current that flows through the resistor? Charge equals current divided by the time, so we kind of more have to focus on the time. So 8 times 60 to give us the seconds, that will equal that will equal, which will equal to 48, and then 12.5 over that, and that's how much amps we have. We can put that in milliamps as 26 milliamps. B, how much power is consumed by the resistor? B equals I squared R. So over here we're talking about resistor, so we need a resistor one. We have the resistance, we have the how much we have of the current, so 0.026 squared times 5,000 equals 3.36, and that will be in watts. So end of the question. Thanks.